And finally, we're arriving to what I promised before, that was the concept of Boolean arrays and also masks or filters. And it's a very interesting and useful topic. It's an amazing feature from the Numpy library, and it's something that will also be borrowed by pandas. So it's going to be very important to understand it. We have exercises for this lecture because we understand that it's something that might be confusing at first. So it's better to practice it before we get into more complicated topics or with real examples with real data later. So to get started, we're going to create a simple array with numbers, and we're going to do a quick review of the multiple ways of indexing that we have with Numpy. So we have, for example, we want to select two elements out of this array, the first one and the last one. We have two ways, or three ways of doing it. Let's start with the basic one. This is something that also applies to regular Python lists. You can just do from this array, I want to get the element at 0, and from this array, I want to get the element at position number -1. That's going to give you the first and last elements of the array. So far so good. This is what you already know from Python. We've also seen in one of our first lectures about Numpy that we can also do multi-indexing. I can actually say from this array A, I want to select all these positions, and you just pass this list of positions. Again, pretty much the same result. The big difference here is we're receiving Numpy arrays as a result. We have a Numpy array, we select from it, and the result is another array. So this is pretty neat, and we're going to use it. And finally, there is a third way of selecting, which at least at the beginning it's going to be a little bit more verbose, but trust me that it's going to make a lot of sense in a couple of minutes. So from this array A, we actually say, I want to select these elements, and we pass an entire list of booleans specifying true for those elements that we actually want to select, and of course false for those that we don't want to select. So in this case, we say, these are the elements that I want to select, and you pass true for the end one and the beginning of the array, false everywhere else. And the result, as you will see, is the same, 0, 5, 0, 5, 0, 5. We have selected the first and last elements of this array. Again, this Boolean array is going to be the core of this lesson, and it's something that we're going to use all the time. Trust me, it's something we're going to use very, very often. But now you might be wondering, why are we going to use something so, so verbose, at least, something that doesn't seem practical enough? What happens if we have, for example, a million different elements in our array? Do we have to type true, false a million times and be careful to put the true values on the elements we want to select? Well, no, you will never be creating these arrays by hand. You will be creating them with Boolean expressions. So if you remember from our Boolean arrays and our vectorized operations lesson, we saw that the result of Boolean vectorized operations with Numpy arrays are actually Boolean arrays. It's an array that contains only false and true values in it. And of course, the results, the true results, are the ones matching the condition you specified. So this was, and again, you can refer back to the vectorized operation lesson, the result is a one-by-one element in A. Let me show you A again. It's an element-by-element comparison of these, or execution of these operations. So is 0 greater than 2? No, we get a false. Is 1 greater than 2? No, we get a false. Until we hit 3, is it greater than 2? Yes, it is, that is true. So we get this true value out. So again, now we're gonna put these two concepts together, the concept of this Boolean vectorized operation and the concept of selecting with Boolean arrays. That means that I can actually feed these result to my regular array A. If I put all that together, and actually I can just copy this thing and show you what it's going to return, A at that, 3, 4, and 5, which are the elements that are greater in the array A, which are the elements that are greater than 2. That's the expression. This is what we get. So actually we can combine all that in the same place, and I can actually say, give me from A the elements that match this condition, and the condition is that the elements have to be greater than 2. If we put all these together, what we end up is with this resulting array. So again, took us just a couple of minutes, but this is a very important topic. We are doing filtering on our Numpy arrays, and this always follows the same form. We have an array, and then we have filters, right, that are just the result of multiple Boolean expressions of the array itself and other values or other scalars or other arrays also. So again, array and the selection within it. We can see a couple of more examples right here. For example, all the elements that are divisible by 2, right? Modulus 2 equals 0. All the elements that are divisible by 2. Let me show you once again our array A, so you can keep it in mind. So we have 0, 2, 4, and that's it, right? So if we pretty much execute that, we get 0, 2, and 4. Which ones from this array A give me all the elements that match these condition for all these elements, right? The ones that return true for this Boolean operation. Internally, if we divide this operation, we actually have a couple of them. First, we have a modulus 2, and we get an array of 0, 1, 0, 1, 0, 1. And then we have the equals 1 equals 0 comparison. So from this array, I can do here, I can do np dot this array, I can do equals 0. And you're going to get true, false, true, false, true, false. We actually have kind of a chain operation. That doesn't matter. We can just put everything together. As long as it's a valid expression, we can put everything together for the filtering operation. Something else is very common to have these dynamic expressions where you don't have anything hard-coded to put in a way. You are creating or you're expressing these comparisons based on other values computed out of the array. So for example, the mean of this array is 2.5. You can say, give me all the elements that are greater than the mean. As simple as that. Now, we've seen in our vectorized operations, and here we are seeing all these Boolean operators, equals, greater, less than, etc. But we also know that there are other Boolean operators, for example, and, or not. These Boolean operators, that these are binary, right? They're going to operate on multiple, some of them are binary, and or, not is actually an unary one. These will also have their NumPy counterpart, and we will also be able to express them as these filtering expressions. So given our array, again, what we can do is we can chain, if you want, the expressions with the and, or, are not, and not operator. So in this case is, give me all the elements that are greater than 2. It's actually not a selection yet. We're just creating the Boolean array in this example. All the elements that are greater than 2, we're actually, let me split it into two different parts. And the ones that are less than 5, and we are going to do now an AND operation here. An AND operation, if you remember from your regular Python classes and your regular Boolean understanding of things, an AND operation will happen only when both values are true. So in this case, we have false and true, the result is false. And false and true, the result is false. True and true, the result is true. Basically here we're saying the elements that are greater than 2, greater than or equals to 2, sorry, and less than 5. So in this case, 2 is greater or equals than 2, greater than or equals to 2, and is less than 5. So the result is true. For an AND operation, both conditions have to be met in order for the final result to be true. True, true, the result is true. The same thing for these two. But then we have that the final one is it greater than 2 or equals? It's 5. It's of course true, but it's not less than 5. It's actually equals to 5. So what's going to happen is that the result is false. The same thing for an OR operation, right? We're combining them. And the same thing for a NOT operation. So this is just a regular NOT operation. What we have right here is we have A is greater than 2. We have false, 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 true and true. And the NOT operator, the same thing that happens with Python. With the NOT operator, what we're doing is we're just inverting the results. So for example, what I can do here is, you know this already. If we have, for example, true, and we do not true, we're going to get false. If we do false, not false, we're going to get true. So this was just a quick recap on regular Boolean operators. So if for these greater than 2, we can actually do a not operator here. And you're going to see is that everything is going to be inverted. False, true, false, true, false, true, true, false, true, false, etc. Anything with the not operator, all the false become true, all the true values become false. It's just inverting all of them. And conceptually speaking, what this means is that we can say, whenever you're doing some sort of filtering, for example, you can say, give me all the elements that are greater than 2, or give me all the elements that are not less or equals to 2. Right, so in this case, the results are the same. False 3 times, true 3 times, false 3 times, true 3 times. The results are the same, but the expression is the opposite, right? Because again, we're using this not operator. Just one more comment before we use these operators for filtering is that you have to be careful of using parentheses for these expressions, because if you don't use these parentheses, what is going to happen, let me show that to you really quickly. What you're going to get are errors because of the order of the operators, right? In this case, you can get errors because the order of the operators is not the one matching because of the just Python how it orders the operators. So now what we're going to do is use these Boolean operators for our selection. In this case, again, we have for A, the array A, we want all those elements that are greater than or equals to 2, all these, but without including those that are only including all those that are less than 5. So we end up only with 2, 3, 5. For these elements to be selected, they need to be greater than or equals to 2, and also they have to meet both criteria. They also have to be less than 5. The Boolean expression result, it tells you which ones it's going to select and which ones will not be selected. So in this case, you have 2, 3, and 4. They are true, true, and true, false for the final one. If we combine all these together, this expression with the NumPy array, we get 2, 3, 4 out. The same thing for this expression, give me all the elements that are either equals to 0 or equals to 1, right? So in this case, again, either. It's any of these criteria is enough, right? That's the way OR works, the same thing for Python. Or again, we can do, give me all the elements that are not less than or equals to 2, and I get this final result out. And finally, to kind of wrap it up, it's very common for us to use these sort of assignments for, these sort of Boolean conditions for assignment. You have a list of users or just values, and you want to replace all the values that match some given criteria by some different value. You can do that very simply just by using a combination of Boolean operators and selection and assignment. So in this case, we're going to replace all the elements that are greater than or equals to 4 with the value 99. And the final result, it's going to be that. You can get it a little bit more complicated. It's just a couple more examples for you to see. In this case, you can actually have sort of a dynamic version of it. It doesn't have to be so complicated. Usually we keep it a lot simpler, but just for you to see that these expressions, as long as they are valid, you can combine them in whatever way you want. So a couple of different patterns you can use for arrays. For example, you know, these Boolean operators will return Boolean arrays, which have a couple of special values. We saw in our let me use parentheses here, in our vectorized operation, we could use sum. So we can pretty much get a count of how many elements meet these criteria. How many elements are greater than 99, right? That's something we can do. There are a couple other methods we can use, like any or n or all, and these, what they're gonna do, they're just gonna ask you, is pretty much the same thing as the functions any and all in Python, and basically what you're gonna get is return true or false if, for example, here any of the elements meet this criteria, or if all the elements meet the criteria. Are all the elements of this array greater or equals to greater than or equals to 99? No, because we actually have 4, right? But are they all less than 1000? Yes, so the result is going to be true. So again, you can pretty much combine all these Boolean operators. There are a couple of exercises because Boolean selection is extremely important. And again, it is something that is also borrowed by pandas. So you folks will see all these sort of expressions and filters all the time.